ICMP, TCP, and UDP are the three primary networking protocols that we use today to transmit information across a network. Let's talk about the similarities and differences between all of them. Well, first similarity, they're all networking protocols. They all send information in packets. So we would consider these layer 4 protocols. Each of them are going to get packed into layer 3 packets, which in turn go into layer 2 frames and get transmitted across the layer 1 physical network. But they are very different in many different respects. So let's first talk about ICMP. So ICMP is a single packet. Okay, so ICMP is a single packet. It doesn't actually transmit large amounts of information. ICMP stands for Internet Control Message Protocol. ICMP is all about making sure that things are working. So if you've used ping or traceroute, you're actually using ICMP for ping or traceroute, sending things like echo requests and echo replies. Those are each ICMP. Now, because they're single packet, they're fairly easy to send across the network. They don't add a lot of congestion, but they're just good ways to check the network connectivity, make sure that things are working, and keep things alive. If you want to know the different ICMP types and codes that make up each of those single packets, Wikipedia has a well-organized page that explains all the different messages that can be sent using a single packet with ICMP. Now, TCP and UDP are multi-packet protocols. So in other words, they're designed to package large amounts of information. So TCP is multi-packet, okay, as opposed to the single packet of ICMP. Now, the other thing about TCP is all about guaranteed delivery. Okay, in other words, using TCP, the Transport Control Protocol, we want to make sure that the information that we send arrives in the correct order. Now, across a local area network, it's not too difficult to send information and have it be received at the other end without getting jumbled up. But when we introduce the internet and a series of routers where there's multiple paths between point A and point B, all of a sudden packets might arrive out of order. And so TCP specifically includes sequencing numbers so that we can make sure that those packets arrive and that they can be reordered in the right order at the destination so that the information is clean. Now, the other piece about guaranteed delivery is we want to make sure that it gets there. So the way that this works is that a computer using TCP is going to send information to another computer. That computer has to acknowledge that information. Yes, I have received that information before computer A will send more information. So how does that conversation work? Well, let's look at two computers. So here's computer A and here's computer B. Okay. Now, in order to initiate this conversation, A needs to make sure that B is ready to talk. And so A is going to send out what we call a synchronized packet, a SYN packet, over to B. B is then going to receive that synchronized packet, and if it's ready to talk, it has to respond. It's going to acknowledge, but it also wants to make sure that A can still talk. So it's going to send out what we call a SYN-ACK, a synchronize and acknowledge packet. The SYN-ACK is going to come back to A, and then A is going to go ahead and acknowledge B. This is what we call the TCP three-way handshake. Okay? It starts the conversation. They get back and forth this synchronize, acknowledge, and now they are locked in a conversation that's going to consist of ACK packets back and forth. So A is then going to start sending information to B. B is going to send acknowledgments back to A. Yes, I've received that packet, I've received that packet, I've received that packet, so on and so forth. Now, of course, it's not one packet that A sends and B responds with one packet. Otherwise, we would essentially be doubling the amount of information that we were trying to send back and forth. So typically, it's 10 to 100 packets, maybe even 1,000 packets that A sends, and B says, yes, I've received all 1,000 of those or all 100 of those packets. But they're going to continue going back and forth with these ACK packets until somebody is done talking. A has sent all the information, B has received it all, it's all in the proper order, they're happy. At which point A is going to tell B, hey, we're done. And so they're going to go ahead and send a FIN-ACK packet, a final acknowledgement packet, and then B is going to go ahead and send back another FIN-ACK to acknowledge that, hey, we are in fact done talking. Okay, and so that's how TCP kind of creates this conversation, acknowledging that everything is sent back and forth. This is for guaranteed delivery. Now, it makes sense that when sending digital data, we really want to make sure that all of the information makes it in the proper order. It's all binary. Imagine sending a novel through the mail where you can only send 10 pages of a novel in each envelope, but you're not sure if the envelopes are going to make it in the right order, and you're not even sure if they're going to make it. And you want to make sure that the recipient received the entire novel, 10 pages at a time. Well, you would expect the recipient to respond, yes, I got the entire novel, or hey, no, I'm missing pages 20 through 30, in which case you could resend pages 20 through 30, something along those lines. But guaranteed delivery, very important for communicating information. Now, UDP, on the other hand, the User Datagram Protocol, is another multi-packet protocol, much like TCP, but there's a slight difference. Rather than guaranteed delivery, UDP is all about best attempt delivery. So where TCP divides information into packets to send, UDP divides information into what we call datagrams to send, and it doesn't necessarily care if the other end receives everything. So unlike this three-way handshake, the initiation is simply A says, hey, B, I'm going to send you some information. B says, okay, and then A sends all of the information in sequence in little bits pretty much as fast as it can. Now you're thinking, well, why on earth would we want to do that, especially across the internet where stuff is going to get lost? Well, consider streaming media, for example, from Netflix or Amazon Prime or Hulu or whatever the popular streaming service is today. If you consider a 1 hour long video or a 45-minute TV show episode, within those 45 minutes, we're talking thousands, hundreds of thousands of packets. If we were to lose 1% of those packets across the internet, you might notice a slight stutter, a missed frame in the video, audio not quite syncing up for just a brief moment, but the overall impact is rather minimal. You don't actually need every single bit of information for your TV show in order to enjoy that media. And so that's where UDP really shines. Even though TCP has very little overhead, it still has overhead. And overhead is what we say when we're trying to send a lot of information and B has to send information back. All those extra packets acknowledging that information received, that increases the total amount of information moved. UDP essentially eliminates that. Now it's true in a UDP stream, if we get out of sync or if B starts to realize, hey, I'm not getting the information that I thought I was going to get, I can ask to restart the UDP stream at a particular point, and UDP will restart back at that point to keep giving me information in order. But this best attempt delivery is all about sending a lot of information very quickly, as long as we don't care if it all shows up on time. So streaming media is a huge example of UDP. Another example of where UDP is commonly used is DHCP, the Dynamic Host Configuration Protocol. When a computer connects to a new network and wants to get an IP address, it doesn't have enough information to do this TCP three-way handshake. So instead, it uses UDP to send out a packet hoping that somebody will respond. If nobody ever responds, that's okay. In TCP, the person would just keep sending that information over and over and over again, trying to find a response that it would never get because it never created this conversation in the first place. So those are our three networking protocols: ICMP, TCP, UDP. ICMP, single packet for controlling or testing communications across a network. TCP, guaranteed delivery. UDP, best attempt delivery.